Um, again, I am sorry. Whoops. All right. All right. So we're actually revisiting something you've seen before, and it's average value, and it's yet another application of the definite integral. So the definite integral is great at adding things up, and then if you divide by however many things you have, you get the average. And it's a much better average than just adding up like the two endpoints and dividing by 2. Okay? I think, what's that? That was like the test, like the mining thing or something. Weren't you mining? You're like digging a tunnel or doing something, digging a tunnel, and I forget if the function was concave up or concave down, but whatever it was, you couldn't just take the first the first endpoint and the last endpoint and divide by 2. The average value really was using the definite integral. So, if you number along with me, you'll find that your homework will be easy. So if we find the average value of f of x on the interval 2, 4, can anyone do that quickly in their head without even doing anything? No? Okay, that's fine. All right, so I need the integral from 2 to 4 of x dx over 4 minus 2. Okay, so let's see. We're good at taking any derivatives. 1/2 x squared. Gosh. Over 2. So 4 squared divided by 2. 8 minus 2 squared divided by 2 is 2. 6 over 2. Hey, it's 3. I thought you said you couldn't take the endpoints and divide by 2. What's up with that? You tell us something and then you give us a problem that proves the exact wrong thing. Why could we take the endpoints and divide by 2?
Linear.
It's linear. Good, Arnie. Awesome. All right. So whenever you have a linear function, right, if we're talking about the average value between 2 and 4, it is. It's 3. That's exactly the same area. It's because these areas are congruent. Okay? This is sort of a little bit of a review, right? Like, I'm not going too fast, am I? No. All right. All right. X cubed minus root x on 0, 1. Oh gosh, sorry. What's bad writing? No, there's no 2. The F? Oh, yep. There. This is horrible. A math teacher that can't write numbers. You gotta love that. All right, so from 0 to 1, x cubed. How am I going to write root x? Yeah. All over 1. All right, great. All right, Sam, x cubed. X cubed.
Okay. It's x to it's 1/4 x to the 4th.
That's what we're talking about. All right, Ian. 1/2 x to the 1/2.
2/3 x to the.
All right, from 0 to 1. Plugging 0 in is going to be great, right? Plug 1 in. 1/4 minus 2/3. Oh, really? Okay, so common denominator is 12ths, right? So 3/12 minus 8/12. Did I do that right? Where am I? Julia, did I do it right? You're actually my algebra person. Any arithmetic people around? Fraction people? Who are my fraction people? All right. It's going to be negative. Wow. That's all right. We can have average values that are negative. No. Because it actually tells me if I'm like, what's the average value for the temperature today? Negative 13. Oh, yeah. I really want to know that it's negative 13, not positive 13. So all this tells you is the value of the function, which is not the same as the area. We're not talking about the average area. We're talking about the value. All right. E to the x on 1 to 4. Oh, this one's going to be easy, I can tell. 1 to 4. Hey, Katie, any derivative of e to the x? You do too. You passed the gateway. Didn't you? Yeah, you did. Okay, Kelly, it is from 1 to 4 all over 3, e to the 4th minus e to the 1st over 3. You alright with that? Do you need me to stop? Say anything? Or any question? That's as good as it gets. That's your exact answer, right? If you wanted to, Morgan, you could go ahead and get like a decimal approximation.
That's a 4, right?
That's a 4, that's a 4. That's a, yeah, okay, I'll get better. I'm sorry. Oh, this is one's going to be good. It's alright, we should not be afraid of trig. Oh, you know what's going to be great, though, when I ask you, alright, what's the, like, cosine of pi fourths? And you're like, I don't know. Someone will remember, though. There's someone who actually liked trig in this class. They might not be here today, but there was someone. Alright. Morgan, any derivative of sine? Good. Oh, you're so ready. Julia, any derivative of negative 1/2 cosine? Are you saying anything out loud? There you go. Early morning speed, but the correct answer. Alright, now, caution. Plugging 0 in is not going to net us 0, so we actually have to take our time and do this. Negative cosine of pi fourths. Cosine of pi fourths? Hey, Julia's that person. Alright, so negative root 2 over 2 minus 1/2 sine of pi fourths? Yeah, it is. So that was sort of nice, right? Now minus, plugging 0 in, cosine of 0? Is that you? Well, it wasn't Katie, but like I didn't see her mouth move. Maybe Katie's a ventriloquist. That was good. That was well played, Katie. All right, so cosine of pi 0 is 1, so that's negative 1 minus the sine of 0 is 0. All over pi fourths. This looks like a fraction nightmare. Negative root 2 over 2 minus root 2 over 4 plus 1 all over pi fourths. Alright, this is not going to be bad because we're going to get a common denominator. I think it'll be okay. Common denominator in the top, 4. So it's going to be negative 2 root 2 minus root 2. So that's negative 3 root 2 plus 4 all over 4. So I changed that to negative 2 root 2 over 4, and I changed 1 to 4 over 4. Got my common denominator. And look, instead of dividing by pi over 4, I could... Yeah, and when I multiply by 4 over pi, nice things happen. Right? The 4's... Tell me the 4 on the bottom of what? It's actually all over pi over 4, but instead of dividing by pi over 4, I'm going to multiply it by 4 over pi. I got a common denominator up here. Right, like that's okay, or right, like I should keep explaining? Okay. Times pi. Oh, it's going to be hard. All right.
Shouldn't it be over pi?
Oh, yeah, that would be better, huh? I can see some of my yesterday has carried over into today. That looks better. That looks much better. Probably even looks like the answer in the back. Drew, stretching or question? Question? All right, so it's going to bother you. But, all right. I think I won't go out of order, I promise. But what I'm going to do is I'm going to take a quick second just to say, no, I won't. Never mind. No, it's all right. So, average area of all circles with radii between 3 and 6. So can you imagine all the circles that have a radii ranging from 3 to 6? That's a lot of them, isn't it? Right? Like an infinite number of them? Yeah. All right, so I need to add up all those circles. Okay, what's the adding tool in calculus? Definite integral. If I want to add circles, what am I adding? Yep, pi r squared. And in this case, this is interesting. In this case, dr, because I'm adding it, r is my variable. So I don't have to, it's not like back when I was doing volume where I had to r and find it in terms of x. R is my variable. The radius is my variable. I don't need it in terms of x or y. I'm just going to keep it in terms of r. And the circles have radii ranging from 3 to 6, so I better divide by 6 minus 3, right? So that will be the average. Got a question. Do you think it's going to be 4.5? Oh, no, sorry. That's dumb. We're talking about the area. Let's see. So 9 pi, and 36 pi. Do you think it's going to be the average of 9 pi and 36 pi? Probably not, because what kind of function is this? The area function? Oh, it is pi r squared.
Quadratic.
Thank you, Sam. Whew. It's quadratic. So the fact that it's quadratic and not linear, as Arnie said, means that it's not just going to be the average of the two. As a matter of fact, because it's concave up, pi r squared, we're probably thinking the average value is going to be less than the average of the two, right? Concavity will help us figure that out. All right, so what's the antiderivative of r squared? 1/3 r cubed from 3 to 6 all over 3. Oh, man. So 6 cubed, 36. 196? No. 216. Hold on. 216. Okay, so 216 over 3 times pi minus, you plug 3 in, 3 times 3 times 3 is 27 over 3 times pi. All over 3? Eee. I don't know. What's 216 minus 27? 09? All right. 189 pi over 3 all over 3. Let's see. 9 plus 8 plus 1 is 18 divided by 3. So do you know that if you add up the digits, if it's divisible by 3, then the number is divisible by 3? Did you learn that in elementary school? Oh, you want me to multiply by the reciprocal first? So you want me to do 189 pi over 9? I can do that. Does 9 go in? Yeah, because if it goes into the last digit, is that it?
No, 9 is the same 3.
Oh, add them up and it goes in by 3? Oh.
No, if it goes in by 9.
Oh, if it goes in by 9. Oh, I didn't learn that one. That's great. Okay. 21 pi? Awesome. And that's actually less than if we took 36 pi and 9 pi, we'd get 45 pi, we'd get 22.5 pi. If we just took the average of the two, don't do that. That's bad. Frowny face. This makes you happy. That's the real calculus average. Okay? Hey, check that out. You can find the average of lots of things. All right, average value of, this one's for you on your own. 4 minus x squared on negative 2 comma 2. Go. Not like leave class. Go, like, do the problem. Did you get something? Sorry. Did anyone just do 0 to 2 and double it? Or no?
But you can't because it's negative, right?
So 4 minus x squared, right? Just a parabola opening downward with a y-intercept of 4. So you could find from 0 to 2 and double it, and that would be the definite integral. You still need to do the average value by dividing by 4. You don't have to. I was just asking if you did. But you can plug in 2 and negative 2.
Does it not work, though, because you have one of the values is a negative?
No, it's totally fine. Or if you could alternately do from negative 2 to 0 and double that. So, Julia, if part of it went below the x-axis, like if you had an equation like this, now you just can't take 1 and double it, because they're actually going to cancel each other out. But because it's all above, right, I'm an okay shape. What'd you get? 8/3?
I got 2 and 2/3, yeah.
For the answer or for the answer, right? Is that divided by, you already divided by 4? What?
You have to just multiply 0 by 4. Wait, what'd you get? It's 2 and 2. I don't know.
Should we do it?
Yeah.
Alright, so from negative 2 to 2, that's 4x, that's 1/3 x cubed. Alright, we good? Oh, sorry. I actually...
I only did. Okay. I didn't do it. Yes.
So we're good then?
Yeah.
Okay, so here's the thing. There's a mean value theorem that we learned first semester, and there's a mean value theorem for this semester. I'm going to just remind you what the mean value theorem last semester was. That was for derivatives, and then I'm going to tell you what the mean value theorem is for this semester. Last semester we said if you have any 2 points, A and B, if you take the average rate of change, which is just the slope between those 2 points, the mean value theorem for derivatives tells you there has to be some point between A and B that has the same slope. And you can imagine maybe that point's like right here. And maybe there's even another point like right here that has that same slope. Alright? So on that interval, the average rate of change, there's another point that actually has that instantaneous rate of change. Is that okay? Alright, the mean value theorem for integrals says, hey, if you find out that the average value for this function is some value c, there's an x value that actually is equal to the average value. There's some interval in that time, there's some value in that interval that gives you the average value. So it's to say like, hey, if today's average temperature is 43 degrees, there actually is a time today where the temperature is 43 degrees. You can't have an average for a continuous function that wasn't actually part of the function. Now, that's different from like your test averages. When we add up your test average and we get that your average is like an 83.4, you probably didn't have a test where you actually got an 83.4 on it. But that's because your test averages aren't continuous. They're discrete values. You're adding up like 3 tests and dividing by something. If it's continuous, if it's a continuous function, then there has to be some value. So like if we said, hey, the average value of the stock market over the last week, was, I don't know, 7,500, right? That means there was some time last week where it actually was that value. Now, you could actually probably argue with me that, like, well, the stock market's sort of a discrete thing, too. Like, you're dealing with, like, eighths and stuff, and, like, it's not totally continuous, but it approximates it. Is that okay? All right? And that should, like, intuitively make sense. So the follow-up question is, when we have a question like the average value is 8/3, we ask, okay, what's the value of x such that f of x equals its average value? Well, that's an Algebra 2 question. When is the function equal to its average value? Well, that's the equation we need to solve. Let's see, what do you want to do? Not yet. What did I do? Didn't you just say root 8/2? Oh, you want me to say 8/3. That's what you're saying. You wrote 8/2. Got it. What am I going to do? Say again? Yeah. Come on. So what do I want to do?
Subtract 4.
Okay, I'll do that. So negative x squared, and how many thirds is 4? 12. So 8/3 minus 12/3, I'm going to get negative 4/3. So x squared equals 4/3, or x equals plus or minus 2 over root 3. So there are actually 2 values, and if you look at the graph, that should probably make sense. If this is the average value of the function, there's a value here and here where the function is equal to its average value. Is that all right? I think that was one of your test questions. It was a multiple choice question toward the end of the test, and I didn't say, like, use the mean value theorem, but I think I said, for what value of x is the function equal to its average value? Yeah. Okay, yeah, that sounds familiar, right? All right, so questions? All right, if f of x equals x minus 2 root x, so this says find the values of c guaranteed by the mean value theorem of integrals. Well, that's just a fancy way of saying find out where the function equals its average value on 0, 2. Okay, so where's the function equal to its average value on that interval? Well, first I have to find the average value. Go ahead and do that. Yeah, go ahead and do that. I have faith. We can pull this off. How'd I do for the average value? I probably beat you. Sorry. Oh, wait.
You have
All right, so when I took the antiderivative, I had 2 here, and then I had to multiply that by 2/3, so that's 4/3. And so then I did 4/3, and I plugged 2 into here, and 2 to the 3/2 is the same as the square root of 2 cubed, which is 2√2.
Can we do most of this on our calculator using writing it all out?